Hello everyone, this is Professor Hitesh Mhatre, HOD Computer Engineering Department of Praveen Patil College of Diploma Engineering and Technology. Today we are going to learn about practical number 3. So practical number 3 is about designing a ER diagram and normalize the database. Practical significance: student should be able to identify the entities and relationship among them. The proper ER diagram should be transformed into proper tables using normalization concept to remove all the updation anomalies for ensuring data dependency. This practical is useful to inculcate these skills in students. Relevant program outcomes: discipline knowledge, experiments and practice, engineering tools, communication, and lifelong learning. Competency and practical skills. This practical is expected to develop the following skill: identify attributes and relationship for a ER diagram, normalize the database using normalization concept, diagram for a given database, draw tables for the normalized database. Relevant course outcome: design normalized database on a given data. Practical outcome: design ER diagram and create normalized database on a given data. Relative affective domain related outcomes: select appropriate ER diagram notations and normal forms, follow safety measures, follow ethical practices. Minimum theoretical background required is about the entity relationship model, entities, attributes, different types of attributes like simple, composite, multi-valued, and derived. These are some symbols like for entity and for multi-valued attribute, simple attribute, derived attribute, composite attribute, links to the attribute, and the relationship. Then we have studied 4 relationship: one to one, one to many, many to one, and many to many. Procedure: consider the database, normalize using normal forms, and draw ER diagrams. These are the specification of the resources, that is minimum required. Then precautions: all SQL statement must end with semicolon, follow safety processes, and these are the actual resources that we have used for this experiment. Now considering the ER diagram for the product order. Now we have studied this ER diagram in a theoretical lesson also. So we have here 3 entities, that is customer, order, and the product. So for to identify a customer, we have ID, name, and a type of customer. For a order, we have order number, address of the order, and the order type. For a product, we have product code, amount, category, and the description. Now to have the relation between like customer and the order, we have customer, places, and order. So places becomes your relationship, and your order includes a product, so include becomes a relationship. So this is the initial first step, that is the ER diagram for your database. Now creating a table. So when you want to create a table, the table will be for the entities. Right, we have your 3 entities, that is customer, order, and the product. So first we will create a table for these entities. So starting with the customer, so here you can see customer table where we have 3 attributes, that is ID, name, and type, same as specified in the ER diagram. Now ID is indicated here by blue, that indicates it is a primary key, that is it is used to uniquely identify this particular record. Similarly for order, we have order number, order type, and address. So these are nothing but your attributes. Your order number is a unique. And for the product, that is product code, category, amount, and description, and your product code here is an unique. So we have these 3 tables created for different entities, but these tables cannot be related to each other because we do not have any attributes that can be used to relate these tables, but we have a relation between these 2 entities. So we have to use something which can help you relate in this table. So here we require is the foreign key. Now the foreign key is nothing but the primary key of the another table. Primary key. So now we will start with the normalizing the database. So this is what the initial table we have. So we'll try to normalize the table. So customer and order are related to each other. So in order to have a relation between customer and order, we will add here order number as a foreign key. Now this is foreign key to the customer, but same is the primary key to the order. Now the concept is that the values present in the order number in the customer table will be the values that are present in the order table. Now you cannot have any random value in this order number. Whatever the values specified in the customer table will be present in the order table. So only from that range you can have the value. So here your order number becomes a relation, that is a foreign key to the customer table, and it is a primary key of the order table. Similarly, order and the product. So your order number, that is your primary key here, we are adding that order number here. So it becomes foreign key. It becomes foreign key. So I can again access the data of this order table because we are related using this order number. Now remains your order table. So in this, since order is related to customer as well as the product, so the IDs of both the table, that is customer ID as well as the product code. So here it will become your foreign key. So this is how your tables will be related. So this is your primary key for that particular table, for that entity. Order number is again your primary key, but in this case it becomes a foreign key because it is primary key of the table that is not part of this customer table. Similarly for the product and the order. So this is how we get your finalized table. So finally we will be creating a table like this, that is customer, in which we will be having a 4 columns. First will be your ID, that will be primary, then name and type, then your order number, which will be referred as a foreign key. Then we will be creating a product table where product code is your primary key. Then we have category, amount and description, and the order number as your foreign key. Then we will create a order table in which order number here is a primary key, order type and order address, and ID and product code of your customer and your product table here will be referred as a foreign key. So I hope you have understand the concept of creating a ER diagram. Then from ER diagram how to create a table, and from create tables you have to normalize, to that is to create a relation between the tables and to check all whether it satisfies all the normal forms. If you have any these are the practical related questions, like draw the notations of the multi-valued and derived attributes, draw the notations of strong and weak entity, and the difference between the strong and weak entity. So we have also covered this in our theory session. Then we have ER diagram. In this you have to identify the derived attributes. Now in this, derived attribute is a return date. Now you can see you have return date here also for a borrower relationship, and you have return date for your student relationship. So return date again derived because based on when the student return, this return will be specified. So it is dependent upon this return date. So it is derived. Then identify the multi-valued attribute. Now actually from this it has not been mentioned, but only email ID holds the way where we can have multiple email IDs. So it can be multi-valued. Then identify the primary and foreign key. Now here the IDs, that is for book ID. Similarly for publisher we have pub ID, and for the student we have student ID. So these can be referred as a primary key, and the foreign key, like for publisher book ID will be foreign key, for book student ID and the publisher ID will be foreign key, and for the student book ID will be foreign key. So these are only depends where it has been used. It can be used as a primary key and a foreign key. So I hope the concept of the creating ER diagrams and tables and normalizing the table is clear. If you have any doubts, you can contact me on these details as shown on your screen. Thank you.